Hi all, since many of you seem to be struggling with the memory game, I thought I'd make this template and send it out to you. There's not too much left to finish here, but I'd like you guys to work at finishing the game up. And to do that, you should understand what's happening here. Now I just want to say thank you to some of the people who did complete most of the memory game. I actually got some great ideas from those folks. So thank you. You know who you are. So so let's go through this quickly. I will send you this code, and what I'd like you to do is finish it up. So first we have the memory game makes use of card objects, and each card represents one of those little cardboard cards in a memory game, a board game, memory game. So let's look at that. So each card has three fields: a Boolean field, showing, which is either true or false. Basically, showing indicates that the card is flipped, right? So that the hidden symbol is showing. A string, which I've called back, which is that hidden symbol on the back of the card, and an integer on the front of the card. This is one of the ideas that was inspired by folks who got this program done early. I'd originally thought that you would enter the row and the column of a card you wanted to flip, but this actually makes that a lot easier. So here's the constructor. It sets showing to false, which makes sense, right? You don't want the hidden symbol to be showing. And it sets the back of the card to whatever's passed in, the string that's passed in, and it sets the front to whatever integer is passed in as the front of the card. Then we have a method showCard, which basically says if showing is true, it shows the back, the hidden symbol, else it shows the front, right? This stuff, string.format, is a way to cause a string to be placed within a specified number of cells. So in this case, it's placed right justified within 10 cells. And here, I'm taking the front, which is an integer, adding it to a left bracket and a right bracket, which turns the whole thing into a string. The S here stands for string, and that will print that right justified in a column of 10 spaces. Okay, you can Google that if you want to know more about it, but it's a useful tool to format stuff. I wouldn't have expected you to do this, but since I'm giving this to you, I thought I would show you how to do that. Okay. Then we have a method called setShowingStatus, and basically this says if it's showing already, set showing to false, else set showing to true. So if this method is called, it basically flips the card from showing to not showing. Okay, and if you call it once, it flips it, and you call it again, it flips it one more time. All right, so that's what's in card. So now let's look at what's in the major part of the game, the other class. All right. So again, this is more complicated. This is more polished than I would have expected you to do. But I thought since I'm giving you this, I might as well show you some of the tricks. So I'm importing a random class, the random class and the scanner class so I can get keyboard input. I have these four fields, a board, which is a two-dimensional, one called board, which is a two-dimensional array of the card objects that we just went over, a straight array of strings containing the hidden symbols, which are just colors, I declare a random object, and a reader object. Now notice none of these, I didn't use new on any of these up here in the fields. You can, but the preferred way to do it is like this. You declare them up here And then down here, you actually initialize them. So R equals new random, that actually creates the random object. Reader equals new scanner system.in, that creates the new scanner object. It allows us to get input from the keyboard. Board equals new card, 4x4. So this is where we actually create or set aside. We don't actually create the cards here, but we do set aside, we build the array that will hold the card objects. The cards are not created at this point. Just the two-dimensional array is created. So then I call shuffle. This is all in the constructor. So let's go look at shuffle. Shuffle should be familiar to you from when we did sorting. It's a simple shuffle method that it has a loop that goes through the array of words and just chooses a random position and swaps the words at the array at the for loop position with that random position. I'm not going to spend any more time on that. That's what swap does. And at the end of that, obviously, the words array is shuffled. Okay. Then I call set cells. Let's go look at set cells. So set cells, immediately you see it's got this nested loop structure. So plus it has a integer variable a, local variable. So outer loop is going to go down through the rows. Inner loop is going to go across through the columns. And what we do is we say board sub row column. So that's a single cell in that two-dimensional array that holds card objects equals a new card. And we pass into that card word sub a. We just pull a is 0. We pull the first word off that shuffled array, and we pass it in as the first parameter. And then a is that integer, and we pass that in as the second parameter. And that's actually this is the hidden word, the back, this, right? And this is the front, the number that's on the front of the card. We increment a so that when we go back and create the next card, pulling the second word off of the shuffled list of words. And then a is 1. So that works nicely. We'll see that in just a minute. So what's next? Set cells, print cells. So let's go look at print cells. So just take a quick look at set cells here, right? The structure of it, the nested loops, reference to the cell in the two-dimensional array. And now print cells, right? Very, very similar, right? The nested loops. But in this case, we're printing the cells. So I have a local variable called a card, which is of type card. And I say, inside the loops, I say a card equals board sub row column. And then I call a card dot show card, right? And so for that particular card, I call it show card method. And just as a quick review, what does show card do? It says if its showing variable is true, then print the back, the hidden symbol, else print the front. And notice that all the cards, when they were made, showing was by default set to false. So it should do the else statement. Sorry, it should do the else statement because when we start out, showing is false. Okay, so this could actually be combined into one statement. I could actually say, instead of saying a card equals board sub row column, right? Because those are basically the same, two names for the same thing, right? That's one way to reference a particular card. This is that same card. So I could instead of doing this in two steps, I could just say board sub row column dot show card, right? But I broke it down here to make it a little clearer. And then the system out println is that when you get to the end of a row, you need to return. Okay? And let's go ahead and make a new one of these. And oh, look at that. Okay, cool. So there's my two-dimensional array. Those are those numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 that are on the front of each card, right? And I supplied that when I made the cards, right? Now let's see. I'll just 0 is, I'm guessing, is 1, and 5 is another. And what happened here is I basically flipped for those two positions. Look at this. I set the showing status to, because the showing status was false, when I called set showing status, it sets it to true. So for those two positions, I set the showing status to true and then reprinted the board. And let's just look at that again. And printing the board calls show card, and show card says if that Boolean variable showing is set to true, print the back, the hidden symbol, else print the front. So for those two cards, the showing is set to true, so it prints the hidden symbol on the back of the cards. Okay? Cool. Final thing. After printing cells, I call play game. Play game, you're going to have to add to this to finish this up. It's one place you're going to have to add stuff. You're going to need a loop here that will keep going. Play game calls choose pair of cards, and that's what we just saw running. So it's pretty straightforward here. I'll go through a couple of things here. I have get input as int as a method. So let's just go look at that. There's a little trick here. So this method uses the scanner object reader to get some whatever you type, but reader.nextLine by default returns a string, right? Even though you've typed like 1, it's the string 1, not the integer 1. But the integer wrapper class has a method called parseInt, which takes a string, and if that string is a legitimate integer, like say this example 34, it turns that into an integer. So that's why this method can return int, because this stuff is turning the string, in this example 34, into the integer 34. Or in our case, it's turning the string 1 through 12, 0 through, whatever it is, 0 through 11, into 0 through 15, sorry, because we have a 4 by 4, into an integer. Okay? So that's what that does. Now, how do we turn that into a row and column? Because that's what we need. Well, we just do some clever use of div and mod, and I'll leave this to you to sort of figure out how that works. But we can extract the row and the column from that single number that they input that's on the face of the card. Okay? We do that for the first card. We do that for the second card. This is a little trick to clear the screen. You don't need to use this, but it will just clear the terminal window. And then I print them again, and that's where it printed it with the backs of the cards showing. You have some more work to do here to check to see if the cards match. If they don't match, you need to set each card's showing status back to false, because they didn't correctly guess those cards. So you have to do that too. Okay? So I hope this helps. You're going to have this code to work off of. If you have questions, please ask them in the discussion on Haiku for the memory game. Okay? Or send them to me directly. Thanks a lot.